Hi there. My name is Charles Costarella. I'm a senior lecturer here at the University of Washington, Tacoma, in the School of Engineering and Technology. And I've been asked to talk to you today a little bit about what I teach here and why I like teaching here and about the School of Engineering and Technology. So I'm going to share my screen with you and show you a few things here. And let me get that going. And we will real quickly start out with some of the topics that I cover. This is a piece of software called Packet Tracer, and it's something that I use in my networking classes. And I teach a lot of networking to both the first year cohort and the seniors. I teach a lot of Cisco type stuff. This software is something that we use in our class to teach TCP/IP networking, and I'll come back to this in just a minute and show you a little demonstration of it. So next up, what you're looking at is a piece of software called Wireshark, and Wireshark is a sniffer, a packet sniffer. It will listen to the network traffic coming across the network interface card on a computer, in this case my computer, and it will report on what it sees, the traffic that's going across that interface. And we can dive into the details of that and look at it and analyze it. We can find out where it's going, where it's coming from, all about it. And I use that in some security classes, some security topics, and also in networking. This screen right here is kind of crowded. But that's because I have a bunch of virtual machines displaying on here. This is what I use for my system administration class. So we teach you how to configure and maintain and implement and stand up services and take care of the servers that form our corporate enterprise networks for all kinds of businesses. We use Windows, as you can see, we've got some Windows servers. I've got a Windows 10 workstation, a couple of those. And on my next screen, I've got a couple of Linux servers. So this is Fedora, kind of an offshoot of Red Hat Enterprise Linux, and also part of our school's VCL or virtual computer lab. And I'll be coming back to each one of these screens and giving a very brief demonstration of what it is we do with that software. And finally, as I said, in the IT program, we also teach programming. It's not only the purview of computer science, so we do a lot of programming in the IT program as well. And I teach a lot of .NET technologies, that's Microsoft technologies, but .NET Core is really becoming very open. It's equally at home on Mac, Linux, or Windows platforms. And this is a piece of software called Visual Studio that we use to do some C#.NET. And I'll also be coming back to this screen. So let me start by going back to the beginning and talking about networking a little bit. So Packet Tracer here, this software is written by Cisco, and Cisco is a big infrastructure company. They make a lot of routers and switches, and they build this software to teach students how to implement networks and configure their boxes. And so we use it to do that same thing. We also have actual real hardware in our routing and switching hardware lab, but of course with the current situation in the world, we're not able to get to the hardware lab. But no worries, we're able to do this through software emulation and teach the same things, just with a little bit less hands-on component. But the students don't miss out on anything. So here I have a little router, and this window that you're looking at is actually the router's interface. So you click on the router and it opens up this little shell. And you can see it's a very Unix-like system. It looks a lot like a Unix or Linux box, and has all the same commands that I gave the wrong command there. It's got all the same commands that a regular router running the real operating system would have, so the students are able to kind of emulate what's going on. And a typical thing that they might do with this software is something like, take this router and then they might add, let's say, a switch to it. So I don't know if you're familiar with networking devices, but there are routers and there are switches. And certainly we have hosts for our network. So we might go here and maybe take a PC and drag it out and then put a laptop out there. And we're going to cable these together using some straight through cables. So again, they can emulate all the same things. I'll hook up my PC and my laptop as well. And so I'll pick another interface here. Put that there. And so you can see the various lights that show that there's no connection here on the red. There's a connection here on the green, but these dots are amber. That indicates that there's not a connection yet, but it's going to be connected as soon as the switch runs through some software protocol or software programs that it's going to do something called spanning tree protocol to check to see if there's any loops in the circuit. And then when it tells that it can detect that there is not, it comes up and turns green. And you can go into any of these boxes and configure them the same as you can if they were real hardware sitting in front of you. So in this way, we can emulate small and large networks. The software is very capable of duplicating things, and we can then just take two networks like this and connect the two networks together and form fairly complex arrangements of networking infrastructure, study all kinds of routing protocols and things like that. And we're really not limited in any way by maybe a budget that wouldn't allow us to buy that much gear for each individual student to play around with. So that's Packet Tracer. That's a little bit about what we do in networking. And of course, we cover all the concepts that go along with that too, so that you understand conceptually what you're doing and why you're doing it and how it works. We tear it apart, look at every little piece, and look at all the different layers of the networking world there. So next up, going to take a look at Wireshark. And Wireshark is our traffic sniffer, and it's going to look at the traffic that's coming across my NIC right now. And what you're looking at is, I'm going to stop this for a second. If I select one of these packets up here in the top section, it actually looks like this section is blue, but that's not correct. It's just that all the packets that are coming through right now are this UDP protocol, and so they're colored blue. But if something else were to come through with some other protocol, it would have some other color. So it's kind of a color-coded thing that you can catches your eye. And there's a pink one up there. You can see TCP. So anyway, when I have it frozen on this packet, there's IP addressing here for both source and destination. That's kind of like the address on your house. There's another window down here that you can dig into, and whatever packet you have selected up here in the top window, this window down here on the left is showing you the details of what's in that packet, and you can dig down all the way to the bottom and find out all about what's in that packet. This is so-called deep packet inspection. I used to use that term. Don't hear it that much anymore, but that's really what it is. It's a deep packet inspection. And you can look down and see source and destination ports, and you can see sizes of things, and you can see checksums and all that good stuff. And then finally, this window over here, this looks like a bunch of, for those of you in the know, that looks like a bunch of hex addresses, hex numbers, and in fact, that's what it is. Those are the hex values of the actual data, the raw data that's being sent across the wire. So there's both a hex view of the data, and then over here on the far right, there's actual ASCII, and that's the actual characters. Like if you typed words, you typed a password, let's say, and it was not encrypted, and it passed across the wire. Say you typed monkey hatchet, then the text monkey hatchet would across the wire, and in Wireshark, if it's not encrypted, you'll be able to see the words monkey hatchet in that plain ASCII text. So we're going to do a quick little demonstration here of that. I'm going to use a website that is provided to me by another professor at University of Massachusetts, Amherst. His name is Professor Kuros, and he sets this up. He writes a book on networking that I have used in the past, and he sets the server up just so that we can use it to do this demonstration. So what we're looking at here is Alice in Wonderland. It's just the text of the book. There's no pictures, there's no GIFs, there's no JPEGs, there's no AJAX, there's no ads that are, annoying ads that are going to pop up or anything like that. This is just plain text in an HTML file. Nothing fancy, no formatting. And that's on purpose. That's because we want to do the most plain kind of, plain vanilla upload that we can. So I'm going to start by right-clicking on this file, and I'm going to save this to my desktop of my local computer. And if I can find it here, there we go. And I'm going to call this alice.text. And there we go. I have it on my desktop now, and I'm going to double click this open and just show you that there is indeed nothing in this file except the story of Alice in Wonderland. It's just a plain ASCII text file. And what we're going to do with this text file is we're going to upload it to another server that Professor Kuros has at UMass Amherst on this page. And what we're going to do here is load the file to get it ready to upload. So I'm going to be the source of the file, and then Professor Kuros's server will be the destination. And I'm going to upload the file. But before I click the upload button, I'm going to start my trace on Wireshark so that Wireshark is listening to my network interface card as Alice in Wonderland starts to stream out of my computer up to his. And then I'm going to look back at the trace of the traffic, and I'm going to see if I can find the title of the story of Alice in Wonderland. See if I can see that plain text that went across the wire there. Okay, so first I'm going to browse to my file, and I left it on my desktop, so I'll go up here. And Alice, there it is, alice.text. So I've got it loaded up here and ready to go. Whoops, didn't mean to do that. And as soon as I click this upload alice.text file, it's going to go across my NIC. So I don't want to do that yet. I kind of have to time this very kind of tricky here in a way. I want to arrange these windows side by side because I'm going to stop the trace here in Wireshark. Remember, I had paused it, but it's actually still going. There's a lot of traffic just as kind of background processes and whatnot. Like my fingers are not even on my keyboard right now. I'm not doing anything on my computer, but you can see that there is some quite a bit of traffic going across, from background processes, communication and whatnot. So I'm going to pause this, okay? And then when I hit the little blue shark fin in Wireshark, that's going to tell Wireshark to start a new trace. There will actually be a warning dialog here though, so I'm going to click that. I get my warning dialog. It says, do you want to save the captured packets before starting? I don't want to save them. I'm going to continue without saving. So I need to click this continue button and then click the upload button. And when the file uploads, I'm going to get a success message here in the browser. And so I have to watch, and as soon as I get that success message, I need to come back here and stop Wireshark as fast as I can. Now, I don't actually have to do that. I don't have to time it that closely because we can filter things in Wireshark, but it just helps. We're going to be looking for a needle in a haystack, basically, and it would help if we have less traffic to look through. So that's what I'm kind of after here. So I'm going to say continue without saving and then hit upload really quickly and look for the success message. So continue without saving, upload Alice. I get that and I stop it. Okay, so I got the congratulations message and I stopped the trace. And you saw just in those few seconds how many packets came across the wire here. I don't know what the count was, but I mean, it's literally up in the thousands there. So there's quite a bit of traffic that had to go across there, or snuck across there, I should say. So now, what I'm looking for here, when my computer reached out to UMass Amherst and tried to talk to that server, it performed part of a protocol, part of the TCP protocol that is very well known in networking. It's called the three-way handshake. And very similar to a handshake in real life, it's a way that the two computers kind of greet each other and agree how they're going to exchange information. It's just like you walk up to a stranger on the street and say, hey, do you know what time it is? And they say, yeah, it's 2 o'clock. And you say, thank you. And they say, no problem. That's kind of a protocol. It's not, it's a set of rules for communication that we have. And some rules are more rigid than others, and computers are pretty rigid in their rules. So they're going to follow this protocol. The handshake kind of goes like this. I'm the client, and I'm looking at the UMass Amherst computer. That's the server. And I start the handshake by saying synchronize. And we call that a SYN message, S-Y-N, synchronize. And the UMass Amherst server answers me back with 2 messages. It says synchronize, acknowledge. So it's sending me a synchronized message, and it's saying, I acknowledge your synchronized message. That's kind of an easy one to spot because they always go together, SYN-ACK. And that'll be the one that we're going to be looking for in this traffic trace. And then finally, I complete the handshake by saying acknowledge back to the server. So once again, I'm the client, I say synchronize. The server says back to me, synchronize, acknowledge. And I complete the handshake by saying acknowledge back to the server. Okay, so we're going to take a look here in this trace. I've moved all the way back to the beginning, and I'm just going to start scrolling down through it. And you can see most of this stuff, UDP, background, something's apparently streaming on my computer right now. Here's a dual message, but PSH, that's not what I'm looking for. There is an ACK there, but there's no SYN message. There's an ACK using TCP. And you'll notice each one of these entries, each one of these packets has a source and a destination IP address. And it might help you if I tell you that this address, 192.168.29.165, that's me. That's my computer. That's the address that's assigned to my computer right now. Don't worry if you don't know what that means. It's not that important. It's just an identifier that I'm going to look for because I know it's me. Now we get into a couple of more pink TCP messages. We've got a TLS message, transport layer security, more TCP, a lot of UDP streaming going on. There was a lot of background noise. I'm not really sure I cleared out my messages before I tried this. I might have to go back and do it again. Here's a SYN message, TCP SYN message, and it is going to, the destination IP address is 128.119.245.12. Now, I don't know what Professor Kuro's machine is. I could probably find out using another little program, but I kind of don't want to. I want it to remain a mystery. I do see that I have a SYN message here, and that's the start of the handshake. And I can also see that it's moving on port 80, and that is the normal port that a web server would be on. So that's kind of cool. I might be getting close here to my handshake. And finally, you can see this packet right here. It says SYN ACK. So the earlier SYN message was me talking to UMass Amherst saying synchronize. And here, we've got the SYN and the ACK coming from, now the source IP address here is the one that was the destination on the SYN message. So the IPs are flipped because his computer is now talking back to me and it's saying synchronize acknowledge. And then finally, the two IP addresses flip spots one more time, and I finish the whole thing by saying ACK back to him. So there's the three-way handshake. Now, I'm looking over here. I've got the final step of the handshake highlighted, and I'm looking at the ASCII characters in that message, and I still don't see Alice in Wonderland. So I'm going to go to the next package, and oh, that's a really big one. Packet, excuse me. And there's a lot of ASCII text over here, and I'm going to scroll down through it, and what do you know? Right about here, you can start to see Alice's Adventures in Wonderland, and it's all broken up kind of funny because of the spacing and everything. But you can see it starts in Chapter 1, Down the Rabbit Hole. Alice was beginning to get very tired of sitting by her sister on the bank. On the bank. I don't know. Never read the story, I guess, that closely. Anyway, so that's just a little demonstration of sniffing a wire for network traffic that's going across there. And you can imagine, hackers and bad actors, they can do this very easily too. They can just sit there in Starbucks and fire up Wireshark and listen to whatever they can from where they're positioned on the network. Now, don't let that make you paranoid. Just use, basic security stuff and be careful that you don't expose things that you shouldn't. But you can see that everything that travels across that network that's unencrypted is vulnerable to being intercepted and read, just like Alice in Wonderland. So we also do some things like track botnets. This little image here is from a well-known West German hacker named Ago alias Wonk. And I did some botnet tracking as part of my master's program, and we talk a little bit about it in our cybersecurity classes. So that's our security piece there. So now I'm going to go on and talk a little bit about system administration. Here I have my Windows server. That's this machine down here. I'm going to log into it. And you can see that I've set up my own domain. My own domain is batman.net.net. I didn't pay for that domain. I just decided to use it. And this is on a virtual network here. So nobody's going to know that I'm using batman.net. That's just my own domain, and all the students in this class make up their own domains so that they can work with Active Directory. That's kind of an identity piece that Microsoft provides that a lot of corporate enterprise networks use. And so again, they get that hands-on experience. And let me log into it. I can remember my password. I did. And you can see that on my server, I've opened up, well, here, I'll close it back up. I opened up the DNS, that's the domain name system. That's kind of the lookup system, the hierarchical lookup system that we use to turn names like Microsoft.com or Google.com or Facebook into the numbers that a computer needs to find things. It turns these names, these canonical names and or fully qualified domain names into the actual IP addresses that the computers need to find each other. Like when I was just looking in Wireshark at those IPs. So here you can see my domain, batman.net.net. And if I drill down into that, you can see some of the computers I have on batman.net.net. I've got a Windows 10 workstation called Joker. And I've got this server, which is called Catwoman. So those are just two of the machines that I have here. And these are entries that we have in the DNS of this faux corporate network that we work with. And so the students will do things like learn how to stand up an Exchange mail server or various different database servers, provide an implementation platform for development, the various different kinds, a LAMP server, WAMP server, .NET Core servers, all kinds of things. But basically what I do with this class is we start with just computers that you would get out like they were out of the box, and we start building them up with the networking, with the system administration, with the servers, with the communication, to the point where we have little groups of 4 students will maybe get issued 6 or 7 different virtual machines, and they will put them together to cobble together a complete enterprise network, which mimics what corporations do in real life, to handle their IT stuff. Because I don't think there's a business out there that doesn't use IT. I mean, I don't care if you're running a tomato farm, you've got something going on in terms of computerized records and stuff. So very good class. And then these other machines that I have sitting around in the background, these are a couple of my Windows 10 workstations. In fact, you saw that there was a machine here called Joker, and this, in fact, is Joker. And you can see I've got the system, I've got the control panel opened up to the system page, and you can see this computer name is Joker, and the full computer name, fully qualified name is Joker.batman.net.net. So you can see this little computer is on my fake domain. Very nice. So, and here's another view of the virtual computing lab, the VCL that supports the School of Engineering and Technology here. This is part of the corporate network too. Here I have a Fedora Linux box, because we teach, both sides. You're going to find both in the industry, so we don't play favorites. I mean, Microsoft, of course, is a huge presence here in the Pacific Northwest, but Linux is always going to be found on corporate networks for various things, and so we teach both sides of things. This is the actual, well, I don't know if you want to call it actual, this is the original login to the Fedora server up here, and then sort of more of a direct view, if you will, and this is the little interface that we use in our virtualized computing lab. I guess you could say that we're at the School of Engineering, we're kind of running our own little private cloud to support, whatever machines students need. If you need a Windows machine and you only have a Mac laptop, that's no problem. We'll issue you a Windows 10 workstation in the VCL. If you need 3 servers to do some research project, you ask for them and they're issued to you. Students do pay a technology fee with some of the courses. It's like, I don't even know what it is. It's not a lot of money, but it pays for all this stuff. And so we have full licensing with Microsoft, with Adobe, with all the major software companies, and almost everything, I would say, comes free within that technology fee. Now, don't quote me on that as in everything, but most things are, sponsored here at the university to help your educational goals, and us as instructors. I mean, it helps to teach a room full of people if as the instructor, that all the students are going to have access to the same technology. There's nothing hindering anybody from using the same stuff. And that's always, it equals the playing field, and it's good for the instructor, because then we can scale the rigor of what we ask the students to do in terms of performance based on, I know that they're all going to have a Windows 2016 server, or I know that everybody's going to have a Windows 10 workstation, or that everybody's going to have a Fedora, server, or whatever it is. So we work very hard to provide this to the students, and we have our own dedicated IT people just for the School of Engineering, Stephen Rondeau and his staff. And then I have some students, some seniors in my system administration class who have worked for Stephen as part of their internship. So our program features an internship where you go out and get a job, usually paid, but some people do volunteer work. And you actually get some actual real world experience to go on your resume for when you graduate. And it's been a great part of our program. So then, last but not least, this is kind of me running home to mama. This is where I came from. My background is in development. I worked for almost 15 years in the software development industry, including several years at the United States Air Force Flight Test Center at Edwards Air Force Base down in sunny Southern California before I came up here. And this is Microsoft Visual Studio, for those of you that do not know. And you can do a lot of .NET programming using Visual Studio, and I'm going to do a little bit right now. I'm going to start a new project, and I'm going to show you how quickly you can use this tool to put up a .NET Core web application. So web applications are extremely popular these days because most of us, take your cell phone out of your pocket and look at it right now. And go ahead and do this while I'm talking. Get your cell phone out and take a look at it. And look at you probably have a calculator on there, right? And so you input some numbers using your fingers on the phone. And so the input comes from you, and it goes into the calculator. And the calculator does some math crunching using the CPU in the phone. And then the output is read to you on the display. So all of the computing takes place right there in your hand, right? Now, I challenge you to find another app on your phone right now that does that same thing. And I mean, the input, the processing, and the output all happen right there on your phone. And I'm betting you can't do it. That's because most of us, the software that we all use, it uses networks. It uses communication. It reaches out to web services. You want to find out where your friends are? Well, that takes a network. You want to find out where that restaurant's located? It's got to use Google Maps or Apple Maps. So most of the software we use are web-based applications. And so this is one of my favorite topics to teach, and where I'm going to put up a very quick and dirty, as they used to say, rough and ready proof of concept that you can build an ASP.NET Core web application very, very quickly using this tool. And so I'm going to select that type of application here, ASP.NET Core web application. You can see that we're using C# as the basic language. C# is Microsoft's flagship language that they use for most of their stuff now. I mean, there's still C++, a lot of C++ in their systems, but C# is real popular. And then I'm going to say next. And on this dialog, I just name the web application. I'm going to name it Contoso University. Now, for those of you that have used Microsoft software development tools, you probably know this name very well. It's one of their sample applications that they've had around for years. They use it in all their tutorials and their online documentation. It's kind of like the Northwind database that used to be in Access. I'm going to let it go to my C drive in the folder that it's saying right there, devel. And then I have this checkbox, place the solution in the project in the same directory. This is all just organizational stuff. So I say create, and I get a second dialog. And this dialog asks me some stuff about the web application itself. So I've already got the one that I want to put up there, a model view controller web application. That's a specific kind of architecture that the kind of the moving pieces of the web application are going to use to talk to each other. So the way that the user puts a request into his browser, clicks on something or does something that sends information to the server, the way the server receives that information in the controller and then decides what to do, kind of like an air traffic controller would direct traffic around, right? And then the way the application responds by maybe going to the database and getting some data and creating what this framework calls a model, and then serves that back to the view. The view is the user's browser that's looking at the application. So we're going to use the MVC architecture. Check and see that we're using .NET Core, not .NET Framework. .NET Core is a little bit newer. It's the cross-platform stuff that works on Linux, Mac, and Windows. And then I'm using ASP.NET Core 3.1. I like using the latest and greatest stuff. I like it when my software breaks. I like it when things go wrong because it's a challenge to me to fix it and to figure out what happened. And so I'm always one of those beta testers, you know. I mean, if you're not of that same kind of mindset, that's fine. I understand. A lot of development shops like to play it safe, but you know, I told you I came from Air Force Flight Test Center, and it shouldn't be any surprise that what they did there was they tested airplanes. And when you test airplanes, you got to kind of push the limits there and see what they can take. So anyway, we've got those two things down. I'm going to click here on the authentication. It says right now no authentication, but I want to talk about this a little bit because it's kind of important. So one of the benefits of using a framework, and this is a framework, ASP.NET Core is a framework. So you could use other frameworks. You might have heard of Ruby on Rails, or you might have heard of Node.js, JavaScript. So those are frameworks. And the frameworks, what they provide you is certain standardized kinds of features that you find in every single website that you go to visit. So almost all websites have some kind of authentication. I mean, it doesn't have to be Bank of America. A lot of websites now want you to log in. They want you to create an account. You know, we've had this taken to its ridiculous extreme with the Facebook, you know, Cambridge Analytica scandal of them gathering data for no good reason. And of course, there's a lot of that. But most applications these days, they have some kind of authentication going on. In this one, you have a choice. You can do individual user accounts. This would be similar to the bank. So Bank of America, they build their web application. They want to control, you know, their users and passwords and whatnot. They want it to be in-house. Or you could go with something like Windows authentication. This would allow you to build a web application and have it piggybacking off of your Active Directory stuff, like the stuff I was just showing you in the system administration class. So there's a tie-in here between the stuff that we teach, you know. I'm going to leave it on no authentication because that creates the simplest sample application. I don't want this to get too complicated. But it's nice to see that the framework takes care of those basic steps so that the developer then can, you know, create more feature-rich web application in a shorter amount of time. Of course, there's a lot of eyes on the security features of these things, and so vulnerabilities are found, but they're found very quickly and taken care of quickly also with some software companies. Not all of them play fair, but most of them do. And they're concerned with their reputations, and of course they respond, somebody like Microsoft, they respond pretty fast. So then, same thing over here, configure for HTTPS. You might recognize the S in HTTPS as security, and that's what it is. I believe a couple of years ago, maybe more than that now, Google and most of the big boys kind of made a silent promise that they're just not gonna route anybody to an HTTP application anymore. it might say that, it might say http:// that might be the scheme in the URL that you click on. But as soon as it gets to the server, you look at your address bar, and I guarantee you it's been redirected to a secure server. So that's pretty standard these days. So I'm going to leave that on, and then we're going to go create and stand back while the sparks fly and fire this baby up. So you can see it did quite a bit for me. It created, I mean, if this was our first shot at Visual Studio, this would kind of be like the Hello World program of web applications. And in terms of a Hello World program, there's a lot of code here that just got created for us. We've got CS code, C# code. Here and here, we've got a startup class and a program class. We've got some JSON stuff in this app settings file. That's the one that has the settings for the application. And then you'll notice we have folders named models, views, and controllers. So there's the separation of concerns that you have in the MVC architecture. Again, the models represent the data. The views represent what's going to go to the user's browser, and they're going to see it. That's what they view when they look at the website. And the controllers are kind of the directors, the ones that are back there in the application on the, on the front of the back end, I guess you could say, kind of directing traffic. They're taking the URL requests and determining what's going to happen and where that's going to go. And so we can just go right to a build here and just see what was created for us. So I'm going to go down here to the batch build, and I'll do both a debug and a release build, and I'll build it, and you can watch my output window and see what happens. With most compilers, no news is good news. And so I got 2 succeeded, 0 failed, 0 skipped. I don't know, that sounds pretty good to me. Better than 2 failed and 0 succeeded, right? So from there, I'm going to run my web application. And now I have a choice of doing this in a lot of different ways. I could go over here to the home index file, which I don't know if you've done any web development. You probably know that this is your de facto, beginning file. This is where they usually start. And I can right-click on that index, CS_HTML, and notice the CS HTML, because it's C# and HTML combined in the same file. So we don't just have static HTML code on the front end. We can actually inject little pieces of C# from the server right into the front, right into the views that the user is viewing in his browser, his or her browser. And then we have this browse with command, and this is the coolest thing, because we have this little dialog that you can see I've got a slew of browsers installed on this machine, and I could browse this application using any one of them. Microsoft Edge, Internet Explorer, the internal web browser, so Visual Studio has its own web browser. It's for kind of, debugging and things like that. Google Chrome and Firefox. And you can see that Firefox is marked as the default. That's not because Firefox is my default. It's specified as the default browser for the application I'm building. So in other words, let's say Firefox was my default browser, which by the way it is, but let's say, and I had my browser set to default to Firefox on my Windows 10 machine. But in this application, I could change the default browser to Google Chrome without affecting my default as a user on the Windows machine. And that way, say my customer came to me and said, well, Chuck, we want you to build us a web application, but we've standardized at our hospital or whatever it is, we all use Google Chrome, and we want you to optimize your web application for Google Chrome. Well, then when I was doing this development, I would set Google Chrome as the default browser, even though my choice of browsers is different. Another thing that's really cool is I could click both of them and say, I want to browse this, I want to open this web application and run it in both browsers at the same time. So maybe I'm trying to standardize things. I'm trying to get the same look and feel between two different browsers. Or maybe I've got a problem on Microsoft Edge and on Google, but not in Firefox. So I can debug only, only the browsers that are showing me the problem. And so it saves quite a bit of time. So after all that, I'm not going to use any of those. I'm going to run this by going up here to the debug menu and just say start without debugging. And now it's going to jump around a little. It actually opened up a browser over on this screen right here. So let me drag it back over. Wow, that was really big. It's actually, let me get it down to my Zoom window size. There we go. And you can see it's showing warning, potential security risk. That's because I wrote the web application and I ran the server. The server's being run inside Visual Studio. But my browser is not recognizing that server as having a security certificate because I don't have a security certificate. So it says, we don't recognize the server, don't trust it. It's a warning, but I'm going to say, you know what? I know that server. I'm going to accept the risk and continue. Now, don't try that at home. Don't do that at Starbucks. But, here in this circumstance, it's fine because I know that I'm the server and I'm not trying to do anything to myself. So here's my web application. It doesn't look like much, but it's got Contoso University as the home page. It's got an actual link to the home page and then a link to the privacy page. And if we wanted to, we could start to play around with this a little bit. We could go to the controller. We could look at the home controller. And I told you this would be like a hello world application, right? And I could go in here, let's say to the index method, which is the method that's going to ask for the index view. And there's nothing here saying that I have to return an IAction result. I'm sorry. Let's look at the privacy method so that we get back to that privacy page. There's no rule saying I have to return an IAction result. I could return a string here, just a simple string. And I might say, hello, advanced admitted student day. That's really awkward, but I guess that's the best I could come up with at the spur of the moment. So I'm going to say that to you. And is it advanced? Let's check the email again. Anyway, I'm going to build that. And I'm going to go back here to my browser. And I'm going to click on privacy one more time. And you're going to see this page change now. And you can see, I know it's hard to see, but it's up there. It says, hello, advanced admitted student day. And so let's go back here again and change it back now. Let's put this back the way it was to an IAction result. And this time we're going to look at the view for privacy. And we've got these little, this is called a data dictionary. It's just a mapping of a parameter to a value. And we can put some others in there. We can add some in. I'm going to call this name, okay? And we'll set this to advanced admitted student. Change that to your name. And then we're going to refer to it here so that we have something spitting out the name. Make this one a little bit bigger. So we'll make that an H2. We'll make your name an H1. How's that? So we'll build that, come back here, refresh the page, and there we go. We've got advanced admitted student in our web application. So, of course, this is a very plain vanilla view of things, and there's lots and lots and lots of stuff you can do to customize it. But we do teach programming in the IT program. And so I hope that gives you a little bit of an idea of what we do at the School of Engineering and Technology. Don't forget the technology. And we would love to see you and chat with you and see if there's any questions that you would have that we can answer. And I hope you have a little bit more of an idea of what we do here at the University of Washington, Tacoma. Thank you, and peace.